business logic separate from your database access layer. Those kinds of things are examples of it. Keep logical separations, and your code will stay clean. Any questions about structure?
Yeah. Where do you fall, on which side do you fall between consistency and bad code? So if I'm coming into a code base and I find poorly written code, but it is rampant, do I go off the beaten path and write good code, or do I write quote-unquote bad code to be consistent with code bases?
Yes. That's a good segue. Perhaps we should talk about, it's not really part of the slides, but I think we could have some interesting discussions around.
Would you do us a favor and repeat the questions?
Oh, okay. I'm sorry. I don't remember what you said. So the question was about what's more important, consistency or writing clean code? If you go into an application and there's unclean code, is it better to be consistent about writing the new code in the same way, or whether or not you should clean it up or write different code that's clean? Well, I mean, that's a good time to sort of segue into why do we have bad code? And it's not really part of the presentation, but I think most of this tends to get into philosophical discussions about why is there bad code. In my mind, there's really two main reasons. One is that the requirements are not completely understood when you start. And two is you don't have time. I think everybody out here, if we had the option, would write clean code. I believe all of us out here have also had the point where we haven't written clean code. And usually, those are the two reasons. Does anybody else have anything that they would say would be a good reason as to why you as a professional developer have had dirty code go out?
Because people just don't care enough to do their job correctly. I think it's, well, to me, I think that's probably the most likely explanation. You have people who are, the job is just a paycheck, they're busy, they've got other things on their mind, they want to do the bare minimum to get by. And you talk about people out there. I said, well, people in this room care enough about programming, that they would spend their non-working hours in an event like this trying to get better at it. I don't think the kind of people you need here are the kind of people who write bad code.
I'll agree, and actually, to be honest, I think I'd add one more, Kevin, and that's they don't know better. So,
basically, when you go, it's got to do with this is really bad. You need to basically divide it up into teams or consolidate things like that. You know, just time, cost, and risk involved with that. Most of the time, they don't want the cost or the risk or the time involved in basically deep like it is.
well, that's. Yeah. Basically, the example that he gave was when you get to as a developer, you go to your management, you say, listen, we found these things that need to really be refactored. Management looks at it, they look at the risk, they look at the amount of time that's involved, and they make a business decision about, we can't do that now. And that, I think, falls really well into there's just not enough time. Because what you'll see is there's a nice arcing line about clean code and time left on the project. So when you're 2 years out from your due date, code looks nice. You're able to refactor it regularly. As new requirements come in, you can change the way it looks, you can change the style. As technology changes, as you're going through your implementation, you can bring that in. However, as you get closer and closer to your due date, the flexibility goes away. At the last minute, you're sitting there, you're getting a sheaf of requirements in. You have to figure out how can you cram them in as quick as possible without affecting the entire application. And in my mind, that's where the biggest massive messy code gets in, is the last 10% of the time of a project.
I think another issue is people tend to get too close to the problem. You look at your own code and you say, I understand it, and it's not until you have distance of time away from it that you can look back and go, what the heck does that mean?
Right? And that is why clean code is important. Even though we've already acknowledged that there's a lot of times that we're not going to be able to develop it and to keep it and to present it like we want to. However, that's why we have to do it. I don't know about anybody else, but I look at my own code and 3 months later I'll look at it and not understand what I was thinking.
And that's what I'm saying. You're too close to it at the time. You can't judge it to be that code because as you look at it, it looks good.
And 10% would be okay with me coming in later if you just said why you did it.
Well, that's
You
it.
just tell me why you did it. At least I know you're under pressure. I can see that. I'd like to know why you did it.
Yeah, as a consultant, you probably wouldn't have me here if there wasn't some kind of pressure. So, anything else about structure? Good structure? And why we end up getting dirty code?
One thing I've seen a lot is putting too much into one method.
Yep.
It's not separation.
Yeah, and then another thing that he brought up is another thing is to have too much going on within one method. Well, I should talk about that a little bit.
Well, one of the things I've seen a lot is, and I've done it, is that as you go through the method, there's several things that's trained in your mind that it gets woven within the method. And so it becomes difficult then to actually factor it out because you have a line from here and a line from there that needs to be factored out. Whereas if you actually separated your thoughts as you wrote that method, broke things out, then you would have this innermost logic.
Right, right, and that's a perfect example of where you get dirty code is a method keeps just growing. It started off as a great method. Did one thing, did it well, did it quickly. Then all of a sudden there was one more thing. So you added another parameter into it to handle this one special case, and then another one, and then another one. And pretty soon you've got a method that's got 10 parameters and is 150 lines long. And it does 15 things rather than the one thing that you expected.
And that method can't be tested.
And exactly, and that method, it can be tested, but it can't completely be tested out. I mean, it's a great segue into this, some of the examples of unclean logic, fragility. One change breaks many things. You can make a change to a piece of functionality by changing an equal than to a greater than or equal to. And all of a sudden, the 10 things that you cared about were working, but the other 20 things that you didn't think about don't work anymore. Those kinds of things are what I would consider fragile code. Rigidity. That would mean you'd have to make a lot of changes to get that one thing done. So in the case where you made the greater than or equal to change, all of a sudden you would have to go back through and refactor. You may end up having 5 or 6 different methods you have to make out of that because your code was too rigid at that point to be able to manage a single change easily. Code duplication, we talked about it a little bit, but sometimes it's easier to do cut and paste than it is to rework a method. If you want all of this, except for instead of it to do this one step here, I wanted to do this last step, let's just copy all of the steps into the new method, and let's take it from there. Code methods with too many arguments. We talked a little bit about as your methods are growing, as the things that you want to happen during that workflow increase, sometimes it's easier just to add a parameter on the method. Well, at some point, that method is going to end up doing, depending on the parameters that you set in, you'll probably end up having a couple of Boolean flags going in to say whether it's this kind or whether it's that kind. It may make it easier right then and there to implement that logic, but it's going to come out and get you in the end. One of my pet peeves is nesting without implicit ends. So if you've got if statements, you've got them nested, so you've got an if statement and then a then statement and things like that. Figuring out where the logic is, can be